What if I told you that uh, there is a perfectly logical, completely mathematically sound universe where 1 plus 1 equals 0?
And, the wildest part is that if you only use the standard rules of addition and multiplication, like the ones we all learned in grade school,
Right.
you absolutely cannot prove that bizarre universe is wrong. I mean, it functions flawlessly.
Okay, let's unpack this because today we are doing something a little different for this deep dive. We are taking a massive step back.
A huge setback, yeah.
Yeah. We're going to look at something you use literally every single day, something you rely on when you're, I don't know, checking your bank balance or having a recipe or just figuring out how much time you have left on a parking meter.
Exactly.
But it's something you probably haven't thought deeply about since you were a beginner, sitting in a grade school classroom.
Yeah.
We are talking about the basic properties of numbers.
It is so incredibly easy to take them for granted. I mean, we balance our budgets, we measure ingredients, we calculate travel times. Right, we use numbers constantly without ever asking what gives them the right to behave the way they do. We just assume that 2 plus 2 is 4, like it's a law of gravity.
Exactly. We treat math like the concrete foundation of a house. You don't question the concrete,
Yeah.
You just build on top of it.
Yeah, you just trust it's there.
But to help us look closer, we are pulling from some classic, really rigorous source material today, specifically the foundational concepts laid out by mathematicians like Michael Spizak in his book, Calculus.
Ah, it's such a brilliant text.
It really is. And our mission for this deep dive is very clear. We are going to explain the core concepts of numbers in incredibly simple language, tailored for absolute beginners.
Right, no scary jargon today.
No jargon at all. We're going to use practical, everyday examples to illustrate what addition and multiplication actually are, like under the hood. And we'll reveal exactly how we use these hidden properties to solve basic equations step by step.
And what's fascinating here is that while these properties seem, at first glance almost too obvious to even mention out loud.
Like painfully obvious sometimes.
Right. But uncovering them is genuinely like discovering the invisible source code of the universe. I mean, once you see the underlying rules, you realize that all of math, literally every equation, every manipulation, is just a consequence of a few incredibly simple agreements we've made about how numbers should interact.
So let's start with the most basic operation of all, addition.
Okay.
Mathematicians usually outline 4 fundamental rules or properties of addition. And honestly, the way they frame the very act of adding completely broke my brain a little bit.
How so?
Well, because intuitively, if I look at a long grocery receipt, right, I see 20 items and I just think, okay, I'm adding 20 things together at once.
Right. You just run your finger down the list and imagine all those numbers pooling into one big bucket.
Yeah, exactly.
But technically, from a rigorous mathematical standpoint, addition is an operation strictly performed on a pair of numbers. Just 2.
Wait, just 2?
Just 2. You can only ever add number A and number B to get a sum. That is the fundamental limit of the operation.
Let me play devil's advocate here because that feels, I don't know, unnecessarily restrictive.
Yeah.
If I look at the numbers 1, 2, and 3, I don't need to break that down. I just look at them and say, well, that's 6.
Ah, but you did break it down. Your brain is just so fast that it hid the processing from you.
Oh, really?
Yeah, you physically cannot add 3 things simultaneously. Your brain either added 1 and 2 to get 3, and then added that new 3 to the remaining 3 to get 6.
Okay, right.
Or you added 2 and 3 to get 5, and then added the 1 to get 6. You chunked it into pairs.
Oh, wow.
And that limitation brings us perfectly to the very first vital rule of numbers, the associative law.
Which basically states that when you are adding, grouping doesn't matter.
Exactly.
But since we are avoiding math jargon, let's ground this in physical reality. Let's use a practical example. Imagine you are moving to a new apartment.
Oh, I hate moving.
Right, it's the worst. But imagine you have a pile of books, a pile of shoes, and a pile of clothes, and you need to pack them all into one giant shipping box to be weighed.
I love this analogy. Let's see how the packing works.
So whether you take the books and the shoes, put them into a smaller inner box, tape it up, and then throw the clothes in next to it.
Okay.
Or if you decide to tape the shoes and clothes together first and then add the books last, the final total weight of that giant shipping box on the scale is going to be exactly the same. The universe doesn't care about your internal cardboard boundaries.
That is exactly it. Because we can only add 2 numbers at a time, We really need a rock-solid rule that guarantees that no matter how we pair them up along the way, the end result is identical.
Because otherwise,
Without this grouping rule, adding three numbers would be total chaos. You'd get, different bank account balances depending on which checks you deposited first.
that sounds like a nightmare.
It would be, but because grouping doesn't matter, we don't need to invent a special new mathematical operation called adding three numbers or adding four numbers. The pair system just scales up infinitely.
Okay, so grouping is safe. Now, I want to talk about what is arguably the unsung hero of the entire numerical world, 0.
Yes, the additive identity.
Right, this is the second rule. And it just means that any number, let's call it A plus 0, remains A. 0 leaves things entirely unchanged.
It sounds almost insultingly simple. Like, why even bother writing that down?
Yeah, I mean, obviously 5 plus 0 is 5.
But defining zero is actually a monumental moment in human history. For centuries, ancient civilizations didn't have a number for nothing. They left a blank space.
Wow, just a blank space.
Yeah. But formally defining a number that has this unique do-nothing property is the anchor of our entire logical system.
Right.
If you add a mystery number to your bank account and your balance doesn't change, that mystery number must be 0. There is no other candidate in the universe.
Which naturally sets us up for the third rule, which is inverses. And this one blew my mind because it changes how you view basic arithmetic. The rule says that for every single number, there is a mirror image, like a twin, that completely cancels it out to 0.
Think of it like matter and antimatter in physics.
Oh, I like that.
For every particle of matter you create, there is an antimatter equivalent, and when they collide, they annihilate each other, leaving absolutely nothing behind.
Right.
So if you have a positive 5, its antimatter twin is negative 5. Combine them, and you get 0.
But here is where it gets really interesting for me. By defining this antimatter twin, you are actually revealing a massive secret about math. Subtraction isn't real, is it?
Not fundamentally, no. Subtraction is an illusion.
That is so wild.
It's just a convenient disguise. It's a shorthand we invented for elementary school students so they wouldn't get confused.
So when you say 5 minus 3,
What your brain is really doing underneath the hood is 5 plus the antimatter twin of 3. You're doing 5 plus negative 3. The operation is, and always has been, addition.
I cannot stress enough how wild that is to realize as an adult. I mean, we spend years treating addition and subtraction as these two separate opposing forces.
Like Jedi and Sith.
Yes, but subtraction is just addition wearing a fake mustache.
Exactly. And it simplifies the universe immensely. We only need to define the rules for addition, and subtraction automatically comes along for the ride.
Which is so efficient.
And that brings us to the fourth and final rule of addition, which is that order doesn't matter.
The commutative law.
Right. 2 plus 3 is the exact same as 3 plus 2.
Again, my skeptical brain says, well, obviously.
But is it obvious in the real world? Think about getting dressed in the morning.
Okay.
Putting on your socks and then your shoes is a very different outcome from putting on your shoes and then your socks.
Yeah, that would look ridiculous.
Right. In life, order matters constantly. But this fourth mathematical rule guarantees that for pure addition, we are safely allowed to swap the order of events without breaking reality.
All right, so we have our 4 fundamental pillars for addition. Grouping doesn't matter. 0 does nothing. Every number has an antimatter twin, and order doesn't matter.
Perfectly summarized.
Now, I want to show the listener how this isn't just philosophy. This is the invisible machinery we use to solve equations. So let's do a step-by-step example.
Absolutely. When you solve a basic algebra equation, you aren't using magic math intuition. You are mechanically firing off these 4 rules, step by step.
Let's do it.
Yeah.
If you're trying to solve an equation in your head right now, let's take the simplest one imaginable. A mystery number, let's call it x, plus 3 equals 5.
Okay, x plus 3 equals 5.
Now, the way I was taught in school was a physical shortcut. You grab the 3, you move it to the other side of the equal sign, it magically flips to a minus 3, and 5 minus 3 is 2. Boom, the mystery number is 2.
And, I mean, that shortcut is great for speed,
Sure.
but moving a number over is not a mathematical property. Objects don't teleport across equal signs. Let's solve that exact equation strictly using the machine code we just learned.
Okay, open up the hood. Walk me through it.
We start with x plus 3 equals 5. Our goal is to isolate the x. We need to eliminate the 3. So how do we do that legally?
We summon its antimatter twin.
Exactly. We add negative 3 to both sides of the equation.
Okay, so now imagine on the left side of the scale, we have a box containing our mystery x and the number 3. And we just dropped a -3 onto that same side of the scale.
That's the setup. But the x and the 3 are currently grouped together in their box. We want the 3 and the -3 to interact and annihilate each other.
Oh, right.
So we use our first rule, the packing boxes rule, the associative law. We shift the grouping, we open the box, and we repack it so the 3 and the -3 are grouped tightly together, leaving the x on its own.
Okay, the boxes had been repacked. So now it's x plus, in parentheses, 3 plus -3.
Yes. Now what happens to 3 plus -3?
By our third rule, matter meets antimatter. They annihilate and become 0.
Spot on. So our left side is now just x plus 0.
And finally, we trigger the 0 rule. Adding 0 does nothing.
The identity property, yes.
So it's x plus 0 simply vanishes into just x.
And over on the right side of the scale, we had 5, and we added the antimatter -3. 5 plus -3, it's 2. We are left with x equals 2. We solved it without teleporting anything.
Now, I have to be honest. If I'm an impatient student, I'm raising my hand right now and saying, well, this seems like a massive pedantic waste of time for something I could do in half a second.
It does, doesn't it?
Yeah, like why spell out all these rigorous steps for just subtract 3?
That is the most common pushback. But if we connect this to the bigger picture, you have to understand that mathematicians don't just work with simple numbers.
Right.
Eventually, you might be working with massive grids of data or abstract geometry or, quantum probabilities, things you just can't do mental math with.
Oh, I see. You can't just look at a spreadsheet with a million data points and intuitively move a 3 over.
Precisely. But here is the magic. If you can prove that your bizarre new quantum math objects follow those exact same 4 simple rules, if they group the same, have a 0, have twins, and don't care about order, then you automatically know you can solve complex equations with them using the exact same machinery.
Wow.
You are learning the universal syntax of logic. You never have to reinvent the wheel.
Okay, that is incredibly powerful. Future-proofing the universe, essentially.
Exactly.
But addition is incredibly slow. I mean, if I have 500 identical boxes, I'm not going to add them one by one. I need a new tool. I need multiplication.
And as we move into the rules of multiplication, you will immediately notice they are the siblings of addition. They mirror each other almost perfectly.
They really do. Let's fast forward to the siblings. Multiplication has the exact same packing boxes rule.
The associative law, yes.
Right. If you multiply 3 numbers, it doesn't matter which 2 you multiply first.
Yeah.
And it has the exact same order rule. 3 times 4 is identical to 4 times 3.
But where the siblings start to show their distinct personalities is with the concept of doing nothing.
Oh, right.
For addition, the anchor was 0. But if you multiply a number by 0, it destroys it.
It becomes 0.
Right. So for multiplication, the do nothing anchor is the number 1. Any number times 1 stays exactly the same.
But there is a massive, almost philosophical caveat attached to this rule in the foundational texts, like Spivak. Mathematicians explicitly demand that we state, for the record, that the number 1 is not equal to the number 0.
Yes, they formally mandate it.
I'm sorry, but this is where I get stuck again. This sounds like an alien trying to write a manual for humans. Of course, 1 doesn't equal 0.
It seems silly.
If I have 1 apple that is completely different from having 0 apples, why do we need a rule for that?
Because in formal logic, you can only play with the toys you bring into the sandbox. If we didn't explicitly forbid 1 from equaling 0, a system with only a single number, just the number 0, would technically satisfy all the mathematical rules.
Wait, really?
Yeah, think about it. 0 plus 0 is 0. 0 times 0 is 0. It works perfectly.
Oh my gosh, so if we don't state 1 and 0 are different entities, the math allows the entire universe to just collapse into a single dark point of nothingness, like a black hole.
Exactly. To force a universe to exist that has more than one thing in it, we have to demand right from the start that our multiplication anchor is fundamentally distinct from our addition anchor. Math requires boundaries to create structure.
Wow. Okay, so we've avoided the mathematical black hole. Now let's talk about the antimatter twins for multiplication.
Inverses.
Right. For addition, we use negative numbers to cancel things out to 0. For multiplication, every number has an inverse, a fraction, that cancels it out to 1.
So the multiplicative inverse of 5 is 1 over 5, or 1/5, because 5 times 1/5 equals 1.
Okay, that makes sense.
And just like we discovered that subtraction was an illusion,
Wait, don't tell me.
division is an illusion too.
Oh my God.
Yeah. Doing 10 divided by 2 is literally just 10 multiplied by the fractional twin of 2. It's 10 times 1/2.
Okay, my whole life is a lie. But there is a massive warning label here, a huge red flashing light on the dashboard. Every number has a multiplicative twin except 0.
Yes.
0 is strictly forbidden from having an inverse. Why?
Think about the mechanism of 0. 0 is a destroyer in multiplication. Any number times 0 becomes 0, period.
Right. 5 times 0 is 0. 0.100 times 0 is 0.
Exactly. So if we wanted to find the multiplicative twin for 0, we would need to find a magical number that, when multiplied by 0, gives us 1.
But that's fundamentally impossible. 0 times anything is 0. It can never, ever be 1.
Precisely. And because division is defined entirely as multiplying by a twin, if the twin doesn't exist, the division cannot exist.
So when we say you can't divide by 0, it's not just a polite suggestion. It's not like a speed limit you can break if you really try.
No, not at all.
It is mathematically meaningless. The machine literally does not have a gear for it.
And trying to force the machine to do it has caused real-world disasters.
Like what?
Well, in 1997, the USS Yorktown, which was a billion-dollar Navy cruiser, was left dead in the water for nearly 3 hours.
3 hours. Why?
Because a crew member accidentally entered a blank field into the ship's database. The software tried to divide by 0, the mathematical gears violently jammed, and the entire ship's propulsion system crashed.
Because you asked the universe to do something it structurally cannot do.
Yeah.
That is terrifying.
Exactly. However, this absolute restriction on 0 gives us an incredible superpower for solving algebra equations. Let's look at the classic factored polynomial that gives every high schooler nightmares.
Oh boy. Okay, let's set it up. Imagine you have an equation that looks like this. X minus 1 inside a box, multiplied by x minus 2 inside another box, and the whole thing equals 0.
We are taught the shortcut in school, to split it into 2 separate timelines.
Right. Either x minus 1 is 0, so x equals 1, or x minus 2 is 0, so x equals 2.
Well, why are we allowed to do that?
Yeah, how does the machine code actually justify splitting the universe in two?
It comes down to the destructive power of 0. Mathematicians prove that you cannot multiply 2 non-zero numbers and magically get 0. It's impossible.
Because they don't have that destroying power.
Right. If I bake a cake and I hand you a slice and you taste it,
Okay.
and the cake tastes like absolutely nothing, if the final product is 0, then at least one of the core ingredients had to be nothing.
So if box A multiplied by box B equals 0, there is no escaping it. One of those boxes must be holding a 0.
Exactly.
They can't both be 5. They can't be 10 and a million. The rules of numbers give us absolute permission to split the problem because 0 leaves no other logical survivors.
That's a perfect way to visualize it.
Yeah.
So up until now, addition and multiplication have been living in separate houses. They're siblings, sure, but they've been doing their own things in their own rooms.
Right.
But obviously, in the real world, you mix them all the time. You add things, then multiply the total. What happens when they interact?
Which brings us to what might be the single most powerful tool in the shed, the distributive law. It is the bridge. It is the only rule that tells addition and multiplication how they are legally allowed to talk to each other. Let's set up a scenario.
Okay.
You have a number on the outside of a set of parentheses, multiplying a bunch of things being added on the inside. But to keep it grounded, let's use a physical analogy.
I'm ready.
Imagine the number on the outside is a delivery driver, and the numbers inside the parentheses, being added together, are individual apartments inside a secured building.
Okay, I like where this is going.
If the driver has a package for the building, he can't just walk into the lobby, hand the package to the very first apartment he sees, and go home.
No, he'd get fired.
Right. If he is multiplying the whole building, he has to distribute the delivery to every single unit inside. Visits apartment A, then he visits apartment B, then apartment C.
And what's brilliant is that you use this delivery driver method every single day, probably without realizing it. Think about how you were taught to do long multiplication. Let's say you are calculating 13 times 24.
Oh, this is a great practical example. If I'm doing 13 times 24 on a piece of paper, I'm doing the classic vertical stack. 4 times 3 is 12. Write down the 2, carry the 1. I mean, it honestly feels like a magic trick you just memorized.
But it's not a magic trick. It's the delivery driver.
Wait, really?
Yeah. When you write down 13 times 24, your brain is secretly rewriting it as 13 multiplied by a building containing 2 apartments, a 20, and a 4.
Because you split the 24 into its 10s and its 1s.
Yeah.
20 plus 4.
Exactly. And now the 13 is your delivery driver. By the distributive law, the 13 has to visit the 20, and it has to visit the 4. So the problem splits into 2 easy chunks.
So it becomes, in parentheses, 13 times 20 plus, in parentheses, 13 times 4.
Yes.
Which is completely manageable in your head. 13 times 20 is 260, and 13 times 4 is 52. Add the results together, 260 plus 52, and you get 312.
And that is the exact same answer you get with the paper and pencil stacking method.
Because the paper and pencil method is literally just a graphic organizer for the delivery driver.
Yes. Every time you shift a row over and add a 0 in long multiplication, you are just keeping track of which apartment the driver is visiting. The distributive law is the hidden engine making the math work.
That is so cool.
Yeah.
And this delivery driver can go in reverse, too, which explains another concept that tortures algebra students, factoring.
Oh, absolutely. Factoring feels like guessing because you are doing the delivery route in reverse.
How so?
Well, imagine you find a baked cake and you want to know the recipe. The cake is the messy expanded equation. Factoring is reverse engineering the cake to find out the ingredients were exactly 2 cups of flour and 1 cup of sugar.
Right.
You're pulling the delivery driver out of the apartments to see who he was before he went inside.
So if the distributive law is this ultimate bridge connecting addition and multiplication, we have to talk about how it solves the biggest, most confusing mystery in all of basic math.
Oh, I know where we're going.
A question that baffles almost every beginner and, frankly, completely frustrates a lot of adults.
Yeah.
Why is a negative times a negative a positive?
It's the ultimate question.
Because let's be real. If I owe you $3, that's a negative 3. If I do that twice, I owe you $6. Negative 3 times 2 is negative 6.
Makes intuitive physical sense.
Right. Debt multiplied by time equals more debt. But negative 3 times negative 2 equals positive 6. Why? Did mathematicians just decide that to make the equations look pretty?
No. And this is where the hidden machinery is so beautiful. It's not an arbitrary choice. The rule is strictly forced upon us to prevent the delivery driver bridge from collapsing.
Okay, let's visualize this without getting bogged down in algebra. No symbols, let's talk concepts.
Perfect. First, we have to agree on what a negative times a positive is. Let's go back to your debt. A negative driver, let's call him a debt collector, visits your positive apartment, he drops off a bill, your wealth goes down.
Right. A negative times a positive is a negative. We agree on that. Debt collector plus my apartment equals sadness.
Now, imagine a negative driver the debt collector is carrying a negative package.
What's a negative package?
A negative package is a cancellation of debt. It's a forgiveness notice.
Okay, I'm tracking.
If the debt collector delivers a cancellation of debt to your apartment, what happens to your net worth?
Well, if my debt is canceled, my net worth actually goes up. I am richer.
Exactly. The negative driver delivering a negative package results in a positive gain for you.
Oh, wow.
But let's step away from the analogy because analogies can break. Mathematically, it works like this. We know that if you add a positive number and its antimatter twin, you get 0.
Right. 5 plus negative 5 is 0.
So imagine our delivery driver is sitting outside a building that contains a 5 and a negative 5. The building itself evaluates to 0, right?
Yes, the apartments annihilate each other.
Yeah.
The building is worth 0.
So if a negative driver visits that 0 building, the total outcome must be 0. Negative driver times 0 is 0.
Sure.
But let's send him into the apartments. He visits the positive 5. We agreed that makes a negative. Now he visits the negative 5.
Okay.
In order for the whole building's total to still safely equal 0, that second visit must produce a positive result to cancel out the first one.
Mind blown. So what does this all mean?
It means math isn't a list of random flashcards to memorize. It's an incredibly tight, highly strung web of logic. If you pulled on one thread, if you aggressively decided, you know what, I think a negative times a negative should just stay negative.
Everything breaks.
You would shatter the bridge, the delivery driver would fail, addition and multiplication would stop talking to each other, and the entire logical structure of the universe would unravel.
You cannot break one rule without breaking the fabric of reality. That is incredibly satisfying to realize. It makes the rules feel earned, not just imposed.
Precisely. And that brings us to the end of the foundational rules for how numbers operate and interact.
But operations aren't the whole story, are they?
Not at all. Mathematics isn't just about figuring out what equals what. It's also about figuring out who has more.
Which takes us to a critical pivot. Addition and multiplication work great in a vacuum, but they don't tell us how big or small something is. If I have a bank account, I don't just care that I can add to it. I need to know if the balance is greater than 0. I need to know if my pile of apples is larger than your pile of apples. And that requires a completely new set of rules.
We are entering the territory of inequalities. Greater than, less than.
Now, normally when we learn this in school, we start with the symbols. The classic alligator mouth that wants to eat the bigger number.
Right, the hungry alligator. But in rigorous mathematics, we don't start with symbols. We start by defining a very exclusive VIP club.
A VIP club.
Yeah, we call this club the Positivity Club, and we build the entire concept of size based purely on who is allowed into this club.
Okay, let's outline the 3 strict rules for getting into the Positivity Club. The first rule is basically a sorting hat for numbers. It's called the trichotomy law.
Exactly.
It says that every single number in the universe must fall into exactly one of 3 buckets. Bucket 1, you are exactly 0. Bucket 2, you're in the Positivity Club. Bucket 3, your antimatter twin is in the Positivity Club.
It forces absolute categorization. You cannot be 0 and positive. You cannot be positive and negative. You must pick a lane.
The second rule is about breeding. If you take 2 numbers that are already in the Positivity Club and you add them together, their offspring, their sum, is guaranteed to also be in the Positivity Club.
2 positives make a positive.
And the third rule is the same, but for multiplication. If 2 numbers are in the club and you multiply them, the result is in the club. Positive times positive is positive.
Okay, so we have this club, but how on earth does a club tell me if 5 is bigger than 3? How do we get the alligator mouth out of this?
Yeah, how does that work?
Well, if we connect this to the bigger picture, the concept of less than is secretly just a subtraction test.
A subtraction test.
Yeah. If I say A is less than B, mathematically, all I'm saying is if you take B and you subtract A,
Yeah.
the leftover result belongs in the Positivity Club.
Oh, okay, let me test that.
Yeah.
If I say 3 is less than 5, what I'm really saying is 5 minus 3 is 2, and we know 2 is in the Positivity Club.
Exactly. A less than B just means B minus A is positive. It turns the fuzzy concept of size into a simple mechanical subtraction check. It's a genius way to define order without needing any new math.
That is so elegant. And this leads to a really cool, fundamental realization about squares. Let's think about taking a number and squaring it, multiplying it by itself.
Let's run it through the sorting hat. A number is either positive, negative, or 0. Let's ignore 0 for a second.
Okay.
If the number is positive and you square it, you are multiplying a positive by a positive. By the club's rules, the result is positive.
But what if the number is negative, like negative 3?
Well, if it's negative, that means its antimatter twin is in the club. And we just spent 10 minutes proving that a negative times a negative is a positive.
Oh. So multiplying 2 negatives puts the result right back into the Positivity Club.
Therefore, no matter what non-zero number you pick in the entire universe, squaring it will always, inevitably, inescapably give you a positive result.
Which gives us a brilliantly simple proof for something so obvious it seems silly. Because the number 1 is just 1 times 1. The number 1 is a square. And since all squares are positive, the number 1 must be greater than 0.
Again, it feels like a joke to have to explicitly prove that 1 is bigger than 0. You can look at 1 apple and 0 apples and know the difference. But we are building from the atomic level here. We couldn't just assume it. Now we have mathematically proven it using the laws of positivity.
And thank goodness we have those laws of positivity, because without them, math gets terrifying. Which brings me back to the hook I teased at the very beginning of this deep dive, the 1 plus 1 equals 0 paradox.
Ah, yes. This is a famous stress test of the rules we've learned so far. It reveals a massive blind spot.
Imagine you are trapped in an alternate universe. A bizarre, claustrophobic mathematical reality that only contains 2 numbers.
Just 2.
There are no 2s, no 3s, no negatives, no fractions. The entire universe consists of only 0 and 1.
Mathematicians call this a finite field, and the rules for how these 2 numbers interact are mapped out on a tiny grid.
Let's look at the addition grid for this universe. 0 plus 0 is 0, 0. That makes sense.
Yep.
0 plus 1 is 1. Still makes sense. 1 plus 0 is 1. Fine. But then 1 plus 1 equals 0. The numbers just loop back around like a clock hitting midnight.
Now, your immediate, visceral human instinct is to reject it. You want to scream, that's wrong, 1 plus 1 is 2, the system is broken.
Right. I have 1 apple, you give me another apple, I don't suddenly have 0 apples.
Yeah.
But here is where it gets really interesting.
What happens?
If you take this bizarre, looping 2-number universe and you test it against the rules of addition and multiplication we just spent half an hour talking about, it passes every single one flawlessly.
It is genuinely unsettling. Does it have a 0 that does nothing? Yes. Does grouping matter? No. Does order matter? No.
No, foolproof.
Does every number have an antimatter twin? Think about it. If 1 plus 1 equals 0, that means 1 is its own antimatter twin. It cancels itself out.
That is so creepy. The delivery driver rule works. Everything works. You absolutely cannot prove that 1 plus 1 does not equal 0 using only the rules of addition and multiplication. Those foundational rules are just too weak to outlaw this weird paradox universe.
So how do we escape it? How do we prove that when we add 1 and 1, We forge ahead into new territory, creating a brand new number called 2, instead of just resetting to 0.
We in the VIP Positivity Club. The inequalities are the cavalry coming over the hill to save our sanity. Let's look at how they destroy the paradox.
Okay, walk me through the destruction.
We just proved, using the rule of squares, that 1 is greater than 0. This means 1 is an official member of the Positivity Club.
Okay, 1 is in the club. Check.
Now apply the breeding rule. If you take two numbers that are in the club and you add them together, the result must also be in the club. So 1 plus 1 must produce a result that is inside the Positivity Club.
I see where this is going.
And by the sorting hat rule, the trichotomy law, if a number is in the Positivity Club, it physically cannot be 0.
Boom! Checkmate. 1 plus 1 cannot be 0. The paradox is defeated.
It's so satisfying.
But it required the concept of size in order to do it. The Positivity Club is what keeps our number system stretching out infinitely into the distance, step by step, instead of just running in a tiny circle forever.
That is just incredibly elegant. I love how mathematicians set that trap. You think you understand everything with addition and multiplication, but it's an incomplete picture. You need the concept of size to force the universe to expand.
And once we establish size and order, we unlock the final tool we need to navigate the mathematical world: absolute value.
Oh, yes.
If inequalities tell us who is bigger, absolute value tells us how far apart things are.
Let's define absolute value for a beginner. Visually, it's a number sandwiched between two straight vertical bars.
Yeah.
Conceptually, it is simply distance without direction.
Imagine you are standing in the center of a city, the 0 point. You walk 5 blocks north. You are 5 blocks away.
Makes sense.
Now go back to the center and walk 5 blocks south. That is the negative direction. But how far did you walk? You still walked 5 blocks. Absolute value strips away the north or south. It just cares about the shoe leather. It is always positive.
And this leads to a heavy hitter concept, something that shows up everywhere in higher math and engineering: the triangle inequality.
The geometry of this is wonderfully intuitive. The theorem states that if you take two numbers, A and B, and add them together, the absolute value of that total will always be less than or equal to the absolute values of A and B added separately.
Okay, let's get out of the abstraction and walk through the city again. Imagine you are trying to walk from your apartment, let's call it point A, to the grocery store, point B.
The most efficient way to get there is to walk in a straight line, the direct path. That is the combined sum.
But what if you decide to take a detour? But what if you walk from your apartment to a coffee shop first, and then from the coffee shop to the grocery store?
Well, unless that coffee shop is sitting exactly on the perfectly straight line between your apartment and the store, your detour is going to require more walking.
Yeah, obviously.
The total distance of the two separate trips will be greater than the direct path. That is the triangle inequality in the physical world. A direct route is always less than or equal to a detoured route.
The geometry makes total sense. But proving it purely with numbers is notoriously exhausting. Because absolute value changes depending on whether a number is positive or negative, traditional proofs force you to check every single possibility.
It's a nightmare. What if A is walking north and B is walking south? What if both are walking south? You have to slog through all these different scenarios to prove the rule holds up.
It works, but mathematicians despise a slog. They view brute force checking as inelegant. And Spivak offers a brilliant, sneaky mathematical shortcut to bypass all that tedious checking.
Oh, I love this shortcut.
Here's where it gets really interesting. How do we cheat the system?
We use the superpower we discovered earlier, squares. We already established that squaring any number immediately forces it into the Positivity Club. It destroys the negative sign.
Right.
And conveniently, the absolute value of a number also destroys the negative sign.
So squaring a number and taking its absolute value are basically achieving the exact same goal, making sure everything's a positive.
Exactly. Because they do the same job, if you decide to square an equation, the absolute value bars become completely redundant. You can just drop them.
Wow.
The math naturally irons out all the wrinkles of positive and negative directions without you having to manually check them. It bypasses the slog completely, allowing you to prove the theorem in just a couple lines of elegant logic.
And we always have to ask the practical questions. So what? Beyond saving a mathematician 5 minutes of writing, what is the real-world takeaway of the triangle inequality? What does this actually mean for how numbers behave?
It gives us a perfect mathematical model for efficiency and conflict. Yeah, if you look closely at how the numbers interact, the two sides of the journey are only perfectly equal if A and B share the same sign. If they are both positive or both negative, they are working together. They are pushing in the exact same direction. Total harmony.
But if they have opposite signs,
Yeah.
if one is positive and one is negative,
Then they are in conflict. They are pulling in opposite directions. One is trying to build the bank account, the other is draining it. They cancel each other out a bit. And the total absolute value of their combined effort will be strictly less than if they had just worked independently. It mathematically proves that opposing forces create a less efficient total output.
wow. We have really covered a massive amount of ground today. Let me try to summarize this journey without just reciting a list of rules. We started with a beginner's goal, right? Trying to understand the invisible machinery beneath the basic math we use to navigate life. We looked at addition and realized our brains are strictly limited to pairing things up, relying on grouping rules and a do-nothing zero to keep things stable.
And we expose subtraction and division as clever illusions, disguises for addition and multiplication. We saw why zero is so destructive that it can crash billion-dollar naval ships if we try to divide by it.
We used the delivery driver to explain how addition and multiplication bridge the gap, proving logically that a negative times a negative must be a positive to save the universe from collapsing.
It's all connected.
It really is. We used the Positivity Club to give numbers a sense of size, preventing them from running in endless loops. And finally, we used absolute values to understand distance, efficiency, and conflict.
Recognizing these underlying mechanisms completely transforms mathematics. It changes it from a rote memorization exercise, just staring at flashcards and hoping you remember the trick, into a highly logical, deeply connected game.
Once you know the rules of the board, every single move you make makes absolute sense. You aren't guessing anymore, you are driving the machine. But as we wrap up, I want to leave you, the listener, with one final, deeply provocative thought. It's a realization drawn right from the closing thoughts of our source material. And it kind of pulls the rug out from under everything we just did.
It really does. It's a huge cliffhanger.
Think about the last hour. We have spent all this time exhaustively outlining the properties of numbers. We talked about how they pack into boxes, how they cancel each other out, how they deliver packages, how they compare in size. We describe how they behave.
Yeah, we never actually defined what a number is.
Exactly. It's the ultimate duck test. We said, if it walks like a duck and quacks like a duck, it's a number. But Spivak points out that these rules are just assumptions. We assumed numbers are familiar objects, and we assign them these rules because they happen to match our human intuition of how the physical world works.
Right.
But do these rules actually account for all the properties of numbers? Are they the whole, complete story?
The foundational texts heavily hint that they are not. In fact, they reveal that there are massive, subtle deficiencies in these basic rules. There are terrifying gaps in the foundation that require incredibly deep, complex, mind-bending math to fix, the kind of math that takes up the rest of a university calculus degree.
So as you go about your day today, balancing your checkbook, measuring coffee beans, or calculating the tip on a lunch bill, I want you to ponder that. If the foundational pillars of basic math we just spent all this time exploring are fundamentally incomplete, what exactly is missing from the numbers you rely on every single day?
You thought you were looking at a solid, perfectly clear X-ray of the universe, but it turns out the bones are still growing.
A perfectly murky diagnostic landscape. Thank you so much for joining us on this deep dive into the hidden machinery of numbers. Keep questioning the foundation. We'll catch you next time.